students have a difficulty remembering the information presented in his lectures. He modelled the percentage of the information retained by the function r equals 100e to the power minus p times t, where t is the number of days after the lecture. My issue is that nobody remembers 100%. Find p. So the value of p, so on the first day 100 equals that, but on the second day 50 equals 100 times e to the power minus p times t, which is 1, so minus p. Now that means that 50 over 100 equals e to the minus p, which means half equals e to the minus p. So ln of half equals ln of minus p. And that doesn't mean it because it's ln of e and we get rid of that. So minus ln half equals p. So p equals, after a day, hang on, so that's ln, or rather minus ln 0.5 equals, so that's, let's do that again, minus ln 0.5, I just put in tan by mistake, so p equals 0.6931, etc. Okay, using this model, find the percentage of information retained after 36 hours, so that's 1.5 days, so that would be B, and that would be R equals 100 e to the minus 0.6931 times 1.5, because that's 1.5 days, and that is, let's find out, so 100 e to the power minus 0.6931 times 1.5 equals, that's 35.36% of the information that they retained, they were given the next day, well, 36 hours before. State a mathematical reason why Professor Way might believe this. They'll always retain some information from his lecture. Well, there is an asymptote, is an horizontal asymptote. So even though it's going down, there's going to come a point where it's not going to go any further. So as a result, they'll always retain something. And then write one possible limitation of the domain of this model. Memory is not a fixed thing, and everybody's works differently, or people have different attention spans. Everybody works differently. I don't know whether that's the right answer. I mean, you could also say there's something quite odd about the idea of talking in days when it comes to memory as well, and that you've not got an exponential amount of days, because at some stage you will all die. It is a fact. Right, Charlie and Daniela began a fitness program. On day 1, they both ran 500 meters. On subsequent day, Charlie ran 100 more than the previous day, whereas Daniela increased her distance by 2% of the distance she ran on the previous day. So, A, Charlie ran on day, how far did he run? So if you do, Charlie's based on an arithmetic sequence, so it's A plus D, A plus 2D, etc. And on day 19, day 20, it would be A plus 19D. So A is 500, and D is 100, And that is 1900 plus 500 is 2400 meters. Okay, now, 2.4. Daniela ran, so she would do A, and then on the next day she'd do A times 1.2. And then on the next day she'd do A times 1.2 squared. So that would be 1. So it would be A times 1.2 to the power 19. So she would do 500 times 1.2 to the power 19, which is, goodness knows what, 500 times 1.2 to the power 19 equals, oh, hang on, that wasn't right, 500 times 1.2 to the power, 19 equals, so 500 times 1.2. I know what it is. I've made a huge error. So it's 1.02, 1.02, 1.02, 1.02. There you go. Now that makes a bit more sense. I was going to say she was running phenomenal amounts. 1.02, so she's just upping it by a small amount every day. Ah, that also makes a lot of sense about something else. Right, 19 equals 728 0.4 meters. B, on day N of the fitness program, Daniela runs more than Charlie for the first time. Find the value of N. So that would be the day when 500 times 1.02 to the power N minus 1 equals more than 500 plus 1 minus N 100. So at that stage, we need to think about, we can basically roll it all out. So 1.02 N minus 1, let's leave that there. So it's 500 plus, so it's N minus 1. How am I doing this? Plus 100 N minus 100 is 400 plus 100 N, and that's 1.02 N minus 1, and then that's divided by 500, so that would be 4/5 plus 1/5 N, 1.02 to N minus 1. We need to log both sides, and then put that under there, and then solve that, and N is, when N is greater than, or when equals 184, so I think it's day 185 would be the time when that would work. Right. This is a triangular field. ABC is such that AB equals 56 and BC equals 82, each measured correct to the nearest meter, and the angle is 105 measured to the nearest 5. So calculate the maximum possible area of the field. So they're each measured to the nearest meter, so AB could equal 55, 56, or 57, so that means the lowest it could be is 55.5 and the highest it could be is 56.5. 82, 81, 83 for BC, so that's 81.5, 82.5. And then finally, the angle is measured to the nearest 5, so that's 105, 110, so that could be 102.5, 105, 7.5. So the maximum possible area, so If we want the maximum possible area, these are the things we're going to have to pick. This one. This one. Now, I don't know what the answer is to sine, because the area equals half sine times AB, sine C to AB. Okay, so let's just do a little drawing of sine. This is 1, this is 2, and this is -1 even. Good Lord. Right, that's 180. So this is going up, so it goes and that's at 90. And then that goes down. So that means that the point where you get the biggest number is going to be 102. So if you put sine 102.5 in, you get, let's just do that again, sine 102.5 equals 0.976. And if we did sine 107.5, we'd get 0.95. So what we need is half times 56.5 times 82.5 times sine 102.5, and that will give us the answer. Times 0.5 times 56.5 times 82.5 equals 2,275.4